Distinction between ammeter and galvanometer. Ammeter, instrument used for determining the magnitude of current presence in the electrical circuit, whereas galvanometer is used for detecting the strength and direction of small current presence in a circuit. Ammeter is calibrated in amperes. Galvanometer has only divisions without calibration. Symbolic representation of ammeter is A. Symbolic representation of galvanometer is upward arrow mark in a circle. Ammeter is to measure the large currents, whereas galvanometer is to measure the small currents. An ammeter can either be a mechanical device or an electronic device, whereas a galvanometer is always a mechanical device. An ammeter may or may not have the magnetic field, whereas a galvanometer always requires a magnetic field. Ammeter is more accurate, whereas galvanometer is less accurate compared to ammeter. Ammeter is less sensitive. Galvanometer is more sensitive.
Galvanometer. A galvanometer is a device used to detect current. With appropriate modification, it can be converted into an ammeter, which can measure currents of the order of an ampere, or milliammeter to measure currents in the range of milliamperes, or microammeter to measure microamp currents. Construction. A light rectangular frame on which a coil on thin copper wire is wound is pivoted between two almost frictionless pivots and placed between cylindrical poles of a permanent magnet so that it can freely rotate in the region between the poles. The poles are suitably shaped and a small soft iron cylindrical core is placed at the axis of the coil, free from the coil to obtain uniform magnetic field. When the current is passed through the coil, a torque acts on it and is deflected. This deflection causes the restoring torque in the spiral springs attached at the two ends of the coil, and the coil attains a steady deflection. The pointer attached to the coil moves on a scale and indicates the current.
A voltmeter is a tool that's used to measure the potential difference between 2 points in a circuit. And on the right here you have a multimeter, which can be used as a voltmeter and ammeter. It can measure resistances, but we're going to talk about it first in voltmeter mode. Voltmeters have an extremely high resistance, and they have this high resistance so that they minimize the effect they have on the circuit. They have very little current flow through the voltmeter, and therefore the circuit remains unchanged, or very close to unchanged. Now, when you connect a voltmeter in a circuit, the voltmeter has to be connected in parallel with the element to be measured. An alternate current path around the element that you're trying to measure should be created as it goes through the voltmeter. If you have it installed correctly, if you remove the voltmeter from the circuit would still function. If we look over here on the right at this example circuit, you can see we have a voltmeter that's connected in parallel with the lamp. So the voltmeter will measure the potential difference across the lamp. It'll measure the potential difference from one side to the other side of the lamp. We've created an alternate path. If, however, we were to remove the voltmeter, we would have an open down here in this loop, so no current would flow there, but we would still have current flowing through the bulk of our circuit, through a complete path there. So removing the voltmeter, our circuit should still operate. An ammeter, on the other hand, is a tool used to measure the current in a circuit. Ammeters have a very low resistance, and they have a low resistance to minimize the potential drop through the ammeter. And once again, the goal is to minimize the ammeter's impact on the circuit. Because they have such a low resistance, if you hook them up incorrectly, it is very easy to go break these devices. So knowing how to connect them is very important. Ammeters are connected in series with the circuit so that the current to be measured flows through the ammeter. It must be broken in order to correctly insert the ammeter. If you can insert an ammeter without breaking the circuit, then you're doing something wrong. If you remove the ammeter, the circuit, or that portion of the circuit you're trying to measure, should stop functioning. It should have an open. So in the diagram at the right in our schematic, we have current flowing through the ammeter and through the rest of the circuit. We have a closed loop path, so we're measuring the total current through the circuit. If we were to remove the ammeter, we'd have an open circuit. No current would flow. Let's take a look at some sample problems to see how this really works. In the diagram, possible locations of an ammeter and voltmeter are indicated by those numbers 1, 2, 3, and 4. Where should an ammeter be located to correctly measure the total current, and where should a voltmeter be located to correctly measure the total voltage? Well, in this case, if we want to measure the total current, let's take a look. We have a positive and negative on our battery there. And if we want to measure the total current, we realize that we have current flowing and current flowing through this loop and back. So if we want the total current, we need to put the ammeter in line with the portion of the circuit where all of the current flows. That looks like our only choice there is 1. So our ammeter must be located at 1. We can get rid of choices 2 and choice 3. Now we want a voltmeter to measure the total voltage. So our choices, where we can measure the total voltage, it has to be in parallel. So I could pick number 4, and that'll measure the total voltage, or number 3, that'll measure the total voltage. If I were to place it at 2, however, that's not going to work. That's in series, not parallel. So it can't be 2. That leaves us answer 1 is the only option, the ammeter at 1 and the voltmeter at 4. That'll give us the total current through the circuit and the total voltage, the total potential difference. Let's take a look at another one. Which circuit diagram correctly shows the connection of ammeter A and voltmeter V to measure the current through and potential difference across resistor R? Now in this case, we want the current through R, and let's take a look. If we look at the circuit, the current through R means that the ammeter must be in series with the loop through R, and the voltmeter, if we want the potential difference across R, must be in parallel. The only option that shows this is down here at number 4. Our voltmeter, you can see, is in parallel with R. If we were to remove the voltmeter from the circuit, it would still function. And the ammeter is in series with R. If we were to remove the ammeter, we wouldn't have any current flow through the circuit. It would create an open. So our correct answer must be number 4.